Structure of a pneumatic system. In this system, an electric motor drives an air compressor. The atmospheric air is sucked by the compressor through the filter. The purpose of the filter is to separate air from suspended and other dust particles. The compressor line is provided with a pressure switch to protect the system pressure rising beyond the safe level by stopping the electric motor supply. Since the compression process increases the temperature of the compressed air, the air is passed through an air cooler to cool the air to environmental condition. This air is then stored in a storage reservoir, usually a large cylindrical steel container. From the reservoir, the compressed air is supplied to various systems for use. Air from atmosphere to air filter to motor power supply, then to air compressor, opens when set pressure is reached, pressure switch, air cooler, storage reservoir, direction control valve, load, air actuator, air to atmosphere. Production of compressed air. Compressed air is produced using compressors and stored in a reservoir. Before the atmospheric pressure is drawn into the atmosphere, it passes through a filter to remove the atmospheric dirt and other particles so that only clean air enters the compressor. In the compressor unit run by an electric motor, the volume of the drawn air is reduced so that its pressure increases. This increase in pressure is associated with an increase in temperature of the compressed air. Hence, an air cooler is used to cool the air before it is sent to reservoir. Atmospheric air inlet to filter, compressor, motor, air cooler, water separator, air reservoir, pressure switch, motor control unit, secondary air treatment, load to atmosphere. Since the atmospheric air is humid after compression and cooling, it condenses into small droplets. This moisture causes corrosion and operational problems. A separator is used to remove water particles from the compressed air. This air, after cooling and separation, that is primary treatment, is sent to the reservoir. Once the reservoir is filled with compressed air and pressure reaches a safe limit value, it is sensed by a pressure switch, which in turn switches the compressor motor off. With usage, the pressure drops down, which is again sensed by the pressure switch and in turn switches the motor on. In pneumatic systems, unlike the hydraulic systems, the compressed air has no lubricating ability. Thus, the stored air before being sent to do some work is mixed with an oil mist. This not only provides lubrication to mating parts but also reduces the corrosive problems. In practice, the compressed air after mixing with oil mist is further subjected to filtering and moisture separation again to make the air further clean. This treated air is then sent to the control valves and to the actuators to do the work. Perfect gas laws. The laws that determine the interactions of pressure, volume, and temperature of a gas are called the perfect gas laws. Even though perfect gases do not exist, Air behaves very closely to that predicted by Boyle's law, Charles' law, Gay-Lussac's law, and general gas law for the pressure and temperature ranges experienced by pneumatic systems. Boyle's law, it states that if the temperature of a given amount of gas is held constant, the volume of the gas will change inversely with the absolute pressure of the gas. V1 by V2 is equal to P2 by P1. Charles' law, it states that if the pressure on a given amount of gas is held constant, the volume of the gas will change in direct proportion to the absolute temperature. V1 by V2 is equal to T1 by T2. Gay-Lussac's law, it states that if the volume of a given gas is held constant, the pressure exerted by the gas is directly proportional to its absolute temperature. P1 by P2 is equal to T1 by T2. General gas law, it contains all three gas parameters: pressure, temperature, and volume. Since none are held constant during a process from state 1 to state 2, it is defined as P1 into V1 by T1 is equal to P2 into V2 by T2.